This is a bench-mounted universal testing machine. It can test specimens both in extension by pulling them apart or in compression by crushing them. The universal testing machine design is based on the Hounsfield design. Hounsfield were the first manufacturers of such machines, and it was a British company. Not much has changed from the original design, from a crank-operated machine to where it is now automated with some software attached to it, in this case called Bluehill. Bluehill is the standard software with this machine manufacturer Instron. Universal testing machines are often referred to as instrons as a shorthand. The reason being is that Instron is the world-leading manufacturer of such machines, and most likely, whether in industry or academia, this is the most commonly found brand of universal testing machine across the globe. The software attached to the machine via the monitor is the latest version of Bluehill, called Bluehill Universal. It is operated via the touchscreen monitor, which has a 4mm thick screen, so that it can be used within industrial settings. Consequently, when inputting parameters into the software, a firm push on the screen is required. On the front of this machine is a safety screen, which is attached via a magnet. So to open it, simply pull on the handle, no latches or locks are required, and then this grants access to the testing area. Here we have two fixing points. This is fixed and stationary. The second point is attached to a load cell. This load cell is interchangeable. Currently, there is a 30 kN load cell fitted into the machine. If materials being tested require larger or smaller forces to be applied, the load cell can be taken out and another load cell inserted. The load cell is attached to a crosshead. The crosshead is attached to the machine through this frame via pulleys, cogs, and lead screws. It is the crosshead which moves up and down. The base fixing here is stationary and does not move. On the side of the frame here is a stop, which is controlled by simply turning the screw, and that can slide up and down. This is a safety feature to prevent the crosshead crashing into the base plate and then stopping the machine and potentially ruining tens of thousands of pounds of equipment. The placement of the stop in the correct location is very important. This large red button is the emergency stop on the machine. If anything becomes tangled or the machine needs to be suddenly stopped in an emergency, depress this button and the machine will shut down. It also shuts down the software and will take several minutes to boot everything back up, but it is there for your safety and others. Next to the emergency stop is a black rocker switch, also referred to as the jog button. This rocker switch moves the crosshead manually. To press it at the top, the crosshead moves up, and press it downwards and the crosshead moves down. Once the specimen is slotted into the first collet, place this collet with its specimen onto the lower fitting. Lift the collar and place the locating pin through the hole and the machine. It is now held securely in place. Take the second collet, take it apart, the pin, the collar, and the two halves, they open out, and place it around the specimen. The large face is at the bottom. Close the two halves around the specimen and place the collar on. Next, lower the crosshead into position. This must be done very slowly and carefully so as not to crash the crosshead into the collet or into the specimen within. To do this, use the rocker switch pressing down, and as the upper fixing approaches the collet, tap it into position, as opposed to pressing and holding. Make adjustments when necessary. and ensure when the crosshead is moving, hands and fingers are out of the way. It's now located, and the crosshead only goes as far as the top of the locating hole, passing the face of the collet. Experience will show that when the collet is lifted, it will be in the right position for the pin to pass through the collet and the upper fixing. But the crosshead shouldn't have gone too far down to press on the specimen, because this is a tensile test pulling the material apart, so there shouldn't be any compressive load on the specimen. The specimen at this point should be loose and rattling around. Then the specimen will be preloaded somewhere between 600 and 1000 newtons before the test is begun. Firstly, close the magnetic front safety screen. This is to ensure safety against projectiles from fractured specimens. The machine will run with the door open. However, where possible, always close the screen.